What's up, guys? Today we will be throwing 4 5-pound watermelons in 3 basketballs off of this bridge. So we got right here, we got 2 watermelons and 2 more watermelons, 2 basketballs, and then we're gonna throw this one at Rozzy. And we might even throw them off the bridge. I don't know. Go. I missed, but at least you jumped.
So first up, we got 1 melon, and we're going for the trampoline down there.
You ready?
Yeah. Okay, are you ready?
Number 2.
Melon number 2. Yeah, go.
Oh my God, bro. Oh, hell no, man. What the man?
Invited this man.
It's gonna hit? Yeah.
Watermelon number 3.
That's up to you. Don't like
Any day now.
Alright. Oh, that's not
Oh, of course this kid will miss. Like, watermelon
Okay.
number 4.
Last one.
Take the ball, I bounce it, I shoot, I miss it. Psych, I switched it.
Bro, of course this kid would miss. Like,
Okay, so we have some calculations on these slides and trampoline down here and then some green thing.
Okay, so what we're finding is how many newtons per meter, which is Spring's constant, can the trampoline produce? And the equation is the force of springs equals K of X, which K is Spring's constant.
Alright, so some of the info we started out with is we used Nate as a measuring tool and stacked him over 5 times to find the height of the bridge, which ended up being 10.4 meters. And this also accounts for how high we held it on the bridge. The diameter of the watermelon is 0.15 meters, and the mass of the watermelon is 2.2 kilograms.
Okay, so first we want to find the position of X of the watermelon after it bounces off the trampoline. So we start where the melon hits the trampoline, which is X naught, and we find how many blocks up it goes using me as the measurement from the previous picture, and we find how many blocks it goes. We actually can figure out that the melon goes up 2.5 nates, or about 4.7 meters.
Okay, so we need to first find acceleration in order to find force. So we could use the kinemass equation right here. And we use this because we don't have the means to find the initial or the final velocity, and we have the initial velocity right off the trampoline is 0. We also know from our video that the time it took for the melon to get to max height, 0.8 seconds.
Alright, so now we can start plugging in numbers. So we put 4.7 for our final position, and then 0 initial position, 0 initial velocity, and then 0.8 for time, and then we get our acceleration of 14.7 meters per second squared. And then we can use that acceleration to find the force the trampoline produces on the watermelon, which is mass times acceleration. We do the mass of the watermelon, which is 2.2 times 14.7, which is the acceleration, and then we get that the trampoline applies 32.34 newtons of force.
Plug.
Okay, so finally we can find Spring's constant, but first we have to find something else. And then I'm going to take a pause real quick because these pictures are kind of hard. So if you want to screenshot them, go ahead.
So what is the X in force of spring equals K of X? So this frame from our video gives us the best look at how far the spring actually stretches. This is X. Since we can see that the top of the watermelon is basically parallel with the frame, we can deduce that the spring went down the length of the diameter of the watermelon, which is 0.15 meters. Therefore, X equals negative 0.15 meters. So X is 0.15 meters.
All right, now that we found all of that, we can finally find Spring's constant. We plug in the force, which is 32.34. We plug in the position that the spring goes down, which is negative 0.15. Find the absolute value of that. We get that the Spring's constant equals 215.6 newtons per meter.
This is watermelon fresh off the ground. We're going to rate it 1 out of 10. Brady, take a piece. Oh, here. What do you rate it?
That's got to be a 10.
Give it a 10 out of 10.
Uh-huh.
Got it. Like the skin.
Anytime now.
Well.
It's a little crunchy. I'll give it 7 out of 10.